We will now determine the domain of this rational function, that is f of x equals 2x over x squared plus 9. So let's consider the numerator as p of x and the denominator as q of x. Basically, we consider the numerator and denominator as functions. So for a rational function, the denominator function should not equal to 0. And so now to determine the values of x such that the denominator does not equal 0, let's try to find out if there are any values of x such that the denominator equals 0. So I'm going to write down this equation for the denominator part equals 0 and try to solve for x. So that is why I have written x squared plus 9 equals 0. Now let's subtract 9 from both sides, so we get x squared equals negative 9. And clearly we don't have any values of x such that its square is a negative number, because when you take a positive number, its square will be positive. Also, when we take a negative number, its square will also be positive. And this means this equation does not have no solution. And so we can easily understand that there are no values of x such that the denominator equals 0. That means there are no restrictions on the domain of f of x for a rational function. So you can say that x belongs to real number system. And so we can write down the domain in interval notation as negative infinity to infinity. And so this is the domain in interval notation. Let's do part B. Here we have this function. This basically is h of r, and this equals 1 over under the root of 2 times of r plus 2. Let me just rearrange this. This I can write down as like this. This equals, just remove this. So I have now written this in proper format. So let's understand this rational function. So once again, for the rational function, the denominator part, let's say if this is p of r, this should not equal 0. And also see that the p of r is basically a square root function. So for a square root function, the domain has to be such that whatever the numbers that you put inside the square root, it should be a positive number. It should not be a negative number. So therefore, we can say that the expression inside the square root, that is r plus 2, this should be greater than 0 and should not be less than 0, because if it is less than 0, then you will get a square root of a negative number which is undefined. So this is one of the restriction, and also we apply the restriction, that is the denominator should not equal 0. So combining these two, we should check if r is r plus 2 is 0. Okay, so first let's solve this inequality. Let's subtract 2 from both sides. So we get r basically greater than negative 2. And this is for the restriction on the square root function. Now let's solve this equation, that is r equals negative 2. So when r equals negative 2, we see that the denominator function equals 0. So we have a restriction on r, that is r should not equal negative 2. So considering these two information, we combine this and give it as the restriction on r. So therefore we can say that the domain of this function is r should be greater than 2 and should not be equal to, I'm sorry, it should be greater than negative 2 and should not be equal to negative 2. It should just be greater than 2. And so this can be written in interval notation as negative, sorry, this has to be negative 2 to infinity. I'm just putting this open brackets and not this square brackets. When you put square brackets, this implies it is included. I'm specifically using this open brackets. So this is the domain of this function, that is negative 2 to infinity. Let's do question 5. Here we have to check if this given function is even function or odd function. So let's use the rule for the even or odd function. To test for an even function, we utilize this rule, that is f of negative x equals f of x. That we see it is an even function. And to test for an odd function, we use this rule, that is if f of negative x equals negative of f of x, we then say it is an odd function. So first, let's test for the even function. That is if f of negative x equals f of x, we say that it is an even function. So let's determine f of negative x. This basically is replacing x by negative x in f of x. So we have to replace x in f of x by negative x. So when I do that, I get 3 times of negative x squared plus 4, and this equal, maybe we should put a question mark here because we are actually testing. So let's check if this is equal to f of x, which is 3x squared plus 4. Let's simplify the left side expression. Negative x quantity square is positive x squared. So this is 3x squared plus 4, and this equals, we are checking, uh, 3x squared plus 4. So basically, we are asking the question if left side expression equals right side expression. Clearly, we have 3x squared, and we also have 3x squared here, plus we have 4 here, and plus we have 4 here. So therefore, these two expressions are one and the same. So this is equal to true, and so we can say that this satisfies the condition for even function. So therefore we say that the given function f of x is an even function, that is f of x equals 3x squared plus 4 is an even function. Let's do question 6. So once again, we test if this function is even, odd, or neither. So first, I'm going to test for even function. So I'm going to use this rule, that is if f of negative x and this equals f of x, we then say that it is an even function. So let's find the f of negative x. We have to replace x by negative x in f of x. So therefore, this becomes 2 times of negative x, and this is quantity cube plus replace x by negative x, so it is negative x minus 5, and this we are basically checking equals f of x. So let's replace f of x, which is 2x cube plus x minus 5. Let's simplify the left side expression. Negative x quantity cube is negative x cube, that is negative x quantity cube. This basically equals negative of x cube. So we will put 2 times of negative of x cube, and this equals negative 2x cube. Since we have to multiply this by 2, 2 times of negative x cube is negative 2x cube, and we have plus times minus, which is a negative number. So we have negative x and negative 5, and this basically we are asking equals 2x cube plus x minus 5. Clearly, we can see that here we have negative 2x cube, and here we have positive 2x squared. So therefore, these two terms are not the same, and we can say that this is not an even function. So since f of negative x is not equal to f of x, we say it is not even. And so we will now check if it is an odd function. So I'm going to use the rule for odd function. That is if f of negative x and this equals negative of f of x, we then say it is an odd function. We have already determined the f of negative x, that is this expression. So let me put this here. We have a negative of 2x cube minus x minus 5, and this equals negative of f of x. So I put negative and then put a bracket. Now I replace f of x, that is 2x cube plus x minus 5. 2x cube plus x minus 5. Let's rewrite this by distributing the negative. So I put the left side expression as it is. And when we distribute the negative inside the terms in the brackets, we will get negative 2x cube, negative x, negative of negative 5 will be positive 5. Now let's check both sides term by term. Here we have negative 2x cube, so here also negative 2x cube. So these two terms are fine. Now we have negative x here, we have negative x here. So these two terms are also fine. But when we check this negative 5 with this 5, the constant term, these two terms are not the same. So we can say that f of negative x is not equal to negative of f of x. It does not meet the condition for odd function. So therefore, since it is not equal, we see that it is not an odd function. It is not odd function. And since it is not even function as well as not odd function, we see that it is neither. It's neither even nor odd function.